All right, so we're going to go ahead and cover 4 different problems from page 34B. This is something you should do on your own, and these are just if you want to go ahead and check if maybe you're confused on how to do them. All right. So we're going to start with number 3. All right. So you should simplify all 3 of these first individually, and then look to see if there's any common radicals to see if they could be combined. So first I'm looking over at this radical 54, or root 54 thirds. See that 54 thirds can be simplified already, so 54 divided by 3 would just be 18. Okay, so we're left with just rad 18. I'm going to simplify, I'll bring these down first, simplify them in the next step altogether. Alright, so right here I see that we have factors of 4 and 7, so we have root 4 times root 7 plus 3. Here we have a 9 times 7, and then here we also have a 9. Alright, so this would just be the square root of 4 is 2, so 2 times 2 is 4. Root 7. Square root of 9 is 3, so 3 times 3 is 9. Root 7, and then right here we have square root of 9 is 3. Okay, so the things that are like terms right here would be these two. So we end up with 13 root 7 minus 3 root 2. Okay, this is fully simplified as neither of the radicals have any perfect square factors left, and they can't be combined. So that's number 3. All right, here's number 5. I think 5 is one of the more tricky problems. So again, we should look to simplify each of these terms individually. All right. So the rad 54, root 54, we have a 9 as a perfect square factor, and then we would have 6. So this is 3 root 6. I'll come back to that one in a second. Right here, this we have a 4 in there, and a 6. So again, this would be 2 root 6. All right, so let's go ahead and tackle the middle now. So with this one, we want to go ahead and get that rad 6 out of the denominator. So we're going to multiple. Let's go ahead and put it as it would be 1 over root 6, seeing as how the square root of 1 is just 1. Now we can multiply by root 6 in the top and the bottom. So we're left with minus root 6 over a regular 6. I'm going to rewrite this so the denominator is more clearly in the bottom. All right, so now we have one with a denominator and the other two do not, so let's go ahead and put it over 1. And we want to go ahead and get those to be common denominators. So let's multiply by 6. Multiply by 6, multiply by 6. All right, here we go. So 6 times 3 is just 18. Notice we're not multiplying the number by the radical, okay? It's just the 6 times the 3. Minus, this would be still root 6 over 6. And this becomes 12. So plus 12 root 6 over 6. Okay, so now we have 3 different things we can add together. Again, luckily these are all like terms, okay? So we end up with 18 minus 1 plus 12, so that should be 29. Yep. So 29 root 6 over 6. Again, double checking. Simplified radical form. There's no radical in the denominators, and these two right here cannot be simplified. Okay. Okay, next let's go ahead and look at number 6. All right, so for number 6, I would say let's go ahead and simplify this root 12. You can either get rid of the radical in the denominator first, or you can take care of it later. So right now, let's go ahead and take this. So this is like root 4 times root 3, so just 2 root 3. Okay, I see that this is 2 root 3, this is just root 3, so in order to make them common denominators, let's multiply this by 2. end up with 8 over 2 root 3 plus 7 2 root 3. And now these have common denominators, we can add them together, so we end up with 15 over 2 root 3. And then to get rid of the radical in the denominator, or to rationalize the denominator, we're going to multiply by root 3. Okay, we end up with 15 root 3 over root 3 times root 3 is just 3, so 2 times 3 is 6. Okay? Right here, be careful. Well, we got to double check, make sure. Okay? No perfect square factors, good. No radical in the denominator, good. But both of these are divisible by 3. 5 and 2. So we end up with the final answer of 5 root 3 over 2. All right. Last problem. Here we go. Okay, so looking at this, you can already kind of see that we're really close to having common denominators to be able to add these or subtract these two terms. So let's go and simplify this first. We remembered that for variables, I'm going to kind of do it off to the side here. We can split this up to the next even. Okay, so it would be like root m squared times m. Okay, and the square root of m squared is just m. So we have m, and then the lone one stays inside. Okay, so this can be rewritten. Okay, just now we need to go ahead and make these have common denominators. So right here we want to multiply by an m on the top and the bottom, and we are now going to have common denominators. So 8m over m root m. Okay, so 6m minus 8m gets us a negative 2m over m root m, and we have a radical in the denominator, so we have to multiply by the radical to clear it out. So we end up with negative 2m root m over m, root m times root m is just m, so we end up with m times m, which is m squared. Now, last thing, we see right here we have an m on both the numerator and denominator. We can simplify that, okay? So this will cross out, and our final answer, I'll write it right here, is negative 2 root m over m. Okay, so that is all the selected answers that I'm going to show you for page 24b. The answer key is available though for the rest of the problem, but these are the only ones that I'm going to go ahead and do and show you. All right, that's it.